everybody, my name is Bruce and welcome to lesson 7. Today we're going to actually spend time in a science lab to investigate how to detect the presence of different cations in solution. By the end of this lesson, you should be able to identify an unknown cation by using analytical methods. When an ionic salt dissolves in water, both cations and anions are present in the solution. Do you remember how cations and anions dissolve in water? This animation should remind you. This process of dissolving an ionic salt is called dissociation. The ions of the solute separate and spread out in the solvent. Please make sure that you understand exactly what we mean by the term dissociation. Dissociation is the process of dissolving an ionic salt. In our previous lessons, we looked at different tests to identify the negative ions or anions. Do you remember the tests we used and the different anions that we tested for? That's right. We tested for halides, in other words, chlorides, bromides, and iodides. We also tested for sulfates using barium chloride and dilute acid. And lastly, we tested for carbonates using dilute acid and clear lime water. Remember, those were our tests for the anions. Today we're going to focus on testing for positive ions or cations. The technique that we are going to use is called a flame test. Let's begin with the experiment. Here I have my 3 samples of my ionic salts, namely sodium chloride, sodium nitrate, and sodium sulfate. Notice that my anions, namely chloride, nitrate, and sulfate, are all different. Yet the cation that I'm using is exactly the same, namely sodium. What I'm going to have to do now is make sure that I record all my observations. Why don't you copy this table down so that you can record your observations while I'm doing the experiment. I will now perform the flame test by using a small length of nichrome wire. Firstly, I will dip the wire into the acid to clean it, and now place the clean wire in the blue flame of the Bunsen burner. I will now use the wire to place a few crystals of sodium chloride into the flame by dipping the wire into the salt so that the crystals stick to it. Watch what happens when I place the wire back into the flame. Let's correlate our observations before we continue. When the clean wire was placed into the flame, the blue flame of the burner did not change color. So you should have blue in the flame color column next to wire. When the sodium chloride was placed into the flame, the color of the flame changed to a bright yellow-orange. I am sure you've written yellow-orange next to sodium chloride on your table. Now we will test the other 2 sodium salts. Let's clean the wire by dipping it back into the acid to make sure that all the sodium chloride is removed before placing it in the flame. Can you see now we have a plain blue flame? Let's dip it now into sodium nitrate and hold it back in the flame. Make sure that you record all your observations. Once again, we must now clean the wire so that we can test for the sodium sulfate crystals. I put the sodium sulfate crystals back on the wire and place it back into the flame. Again, make sure that you write down all your observations. Let's now check all the observations we've made. At the end of this experiment, your observation table should look something like this. I am sure you will agree that all the sodium salts burnt with a bright yellow-orange flame. What conclusions can we make from this experiment? Well, firstly, we could see that the different anions of the salts played no role in influencing the color that we were able to observe. Secondly, that all the sodium salts burnt with the same yellow-orange color. But what about other ionic salts? Will they burn with the same flame color? Let's take a look. This time, we will be testing the following substances: potassium nitrate, lithium carbonate, and copper chloride. Remember that you have to draw up a table for your observations and that you have to clean the wire before testing each salt. We will start by testing the potassium salt. Right, I will now clean the wire and we'll move to the lithium salt. And finally, we'll move to copper chloride. Did you write down all your observations? Let's check them. The potassium salt burnt with a pale purple or lilac flame, which you would have seen at the edges of the flame in the test. The lithium salt burnt with a red flame, and the copper salt burnt with a blue-green flame. What conclusions can you now make from these two experiments? Well, there are two main conclusions that we can draw from this experiment. Firstly, we can now safely say that it's the cation that causes the flame to burn with a particular color. And secondly, that different cations burn with different color flames. Scientists have repeated this over many years, and we can now use the flame test to positively identify different cations. Let's now recap all our results. Sodium salts burn with a yellow-orange flame. Potassium salts burn with a pale purple or lilac flame. Lithium salts burn with a red flame. And copper salts burn with a blue-green flame. Can you guess where we see this chemistry in action? The different colors of these fireworks are produced by different cations. There are, however, cations that are a little bit too complex and cannot be identified by using the simple flame test. The ammonium cation is an example of such a complex cation. This is the chemical formula for ammonium. It is made up of nitrogen and hydrogen with an overall charge of +1. I will now show you two simple chemical tests which will allow us to identify the ammonium cation in an ionic salt. For this experiment, we will use ammonium sulfate as our salt. In our first experiment, we're going to use a mixture of calcium hydroxide and ammonium sulfate. Firstly, I'm going to place some calcium hydroxide into a test tube, like this, and then some ammonium sulfate. I now mix the two together, and now we'll gently heat the mixture. This might take a few seconds for the chemical reaction to start. What I will now do is take a piece of damp litmus paper and hold it at the neck of the test tube. Do you notice what happens to the litmus paper? Did you notice that the litmus paper turned blue? Now, this is a good indication that a gas was given off and that gas was highly soluble in water. Well, what could this gas be? Well, ammonia gas is highly soluble in water and will turn litmus paper blue. Thus, we can conclude that if ammonia gas is produced, it must have come from an ammonium salt which contains the ammonium cation. If you look at the equation, you can see that this is an ion exchange equation. The calcium cation is attracted to the sulfate anion to form an insoluble product. At the same time, the ammonium cation is attracted to the hydroxide anion. But the ammonium hydroxide is not stable, and when heated, it decomposes into water and ammonia gas. There's also another very simple test for ammonia which we can perform. Let me show you. For this experiment, we need to repeat the initial steps of our previous experiment. I'm now going to heat the test tube again over the Bunsen, making sure that I shake it to try and generate as much gas as possible. What I'm now going to do is bring a bottle of hydrochloric acid near the neck or mouth of the test tube. Now watch what happens. Can you see thick white fumes forming at the mouth of the test tube? This is a positive test for the presence of ammonia. Now let's have a look at the equation for the reaction. In this reaction, the ammonia gas combines with the hydrogen chloride gas to form the solid substance ammonium chloride. This is observed as the thick white fumes at the neck of the test tube. You can also identify ammonia gas by simply smelling it. It's not a very good scientific test, but it's important to know that ammonia gas has a very sharp, distinctive smell that irritates your nose and will even make your eyes water. In fact, ammonia-based products can be found in most households. It is commonly found in cleaning detergents. Let us now summarize what we have learnt in the second part of this lesson. Simple cations such as sodium, lithium, potassium and copper can be identified by using a flame test. The ammonium cation can be identified by heating to produce ammonia gas, and one can test for ammonia gas by using red litmus paper or by using hydrogen chloride gas. I hope you have enjoyed learning about the variety of chemical tests that we can use to identify different cations. Until next time, thank you and goodbye.